In this session, students, we will in fact fit the regression model properly because this is what the requirement of question number 3, and we have to see what are the options we need to take when we are going to fit a regression model between two variables, because checking whether the fitted model is following assumptions of classical linear regression model or not is of immense importance, because the acceptability of the fitted regression model depends upon following assumptions. Now, what we do, we go for analyze. Before fitting the regression model, I am doing one more thing. Correlation I am obtaining between these two variables. How to get correlation matrix between two or more than two variables. This is what the option we can use. Analyze, correlate, bivariate. We move both weight and price together in this analysis area for the variables, then paste. Then we go for, again, we select this entire syntax and we run selection. This is how we get the coefficient of correlation values. And on top of these values, you can see two static marks are indicated, and the description is given over here that correlation is significant at the 0.01 level of significance to date. Now we are going to fit the regression model. That's all the requirement of our question number 3. So analyze regression linear. We take price on dependent. We take y as dependent variable. Then we go to statistics. We mark a check across confidence intervals. Continue. Then we click plots button. We take z resid as y-axis variable here, z predicted as y variable over here, so that we can in fact check whether the independence of residual assumption has been followed by the regression model or not. Similarly, we mark a check across histogram option. We mark a check across normal polyplot. Marking check across these two options will compare the distribution of residual with the normal distribution. To what extent the residual or the behavior of residual is similar to the normal distribution or not. This is what it will focus on. Now we click continue and then we click save button. In save button, we will go for marking a check across predicted values, unstandardized category, residuals, unstandardized. Unstandardized means that the variables are we are looking for or we are examining are not adjusted according to their mean and their standard deviations. That is transformation to normal distribution, z distribution. So we click continue and now we click paste, and then again we go to this syntax file and we select and then run the statement or the syntax. This is how we get the regression model. We have interpreted R square already. We can quickly go through what are the results we are getting when we have selected these options, so many options. So analysis of variance table we get that again focuses on goodness of fit perspective of the regression model, and if we would like to generalize our opinion that the model is a good fit model, then we need to perform a particular hypothesis test for the goodness of it. Similarly, we get a coefficient stable. Over there, the this is minus 259.626. Over there we were getting 260, and 3720 over there we were getting, you can recall, match with the earlier findings when we have fitted the same model on the scatter diagram. Almost a closer values to the ones we are given in this table we found over there. So constant, again negative sign, and minus 259.626. Weight has a coefficient value 3721.025. Their standard errors we are given. Their beta conversions or coefficient we are given, standardized coefficients. Their t values we are given. T values we will be using to perform hypothesis test again, and associated significance, because we are going to follow p-value approach, so significance or p-values are needed over there. Then 95% confidence interval for the betas. Over here important is the 95% confidence interval for the weight coefficient, because what is the minimum possible and maximum possible change that a unit increase or change in the independent variable causing in the dependent variables causing. Then residual statistics, again it will fulfill the assumptions. Then this histogram of residuals, and on this you can see a normal curve is fitted, so that we can identify that to what extent this normal curve is a good fit on this histogram, so that we can draw a conclusion using this graph that whether our residuals follow normal distribution or not. Then we have QQ plot, normal PP plot, that would again help us to identify whether our residuals are moving closer to this line or making a non-linear trend with respect to the line. Then this is again another graph that we will make use of to understand or to assess this, the assumption whether residuals are independently distributed or not. So these are the things that we get. Now one by one we will try to answer the questions given in this task sheet. We have fitted the model, and then question number 4. In question number 4 we have discussed the model already. We have interpreted regression coefficients, coefficient of correlation, and coefficient of determination, all in the previous lecture video connected to the same content. Then in part 5, question number 5, we are asked to determine estimated prices and residuals. Now you can see, go to the data file. Over there we have two more columns added to our data file. We can see easily. The first one is the predicted values that the software has computed after fitting the model on the data, and then residuals based upon the difference between actual price and the predicted price. So software has computed this value as the difference between these two values. Okay, so this is how we have answered already question number 5 as well. Now we need to answer the next part. Do residuals follow normal distribution? Support your findings on the basis of QQ plot. Now what we do, we know that to perform normality test for any variable we need to go for explore option in SPSS, and we'll just select normality plots with test option in plots option. So I am doing it again. This time we will perform this test for residuals, whether residuals follow normal distribution or not. So we go for analyze, descriptive, explore. We reset this. We take unstandardized residuals as dependent list variable. We go for plots. We mark a check across none. Then normality plots with test should also be marked because this is what we are focusing on right now. Continue and then paste. We will select this entire syntax and then run this syntax. And this is what the table is. Now we can see test of normality for unstandardized residuals in terms of both Kolmogorov-Smirnov and Shapiro-Wilk test. Now what we do, we will perform formally the test. Over here, I will do the write-up for this test. And the test or the H naught related to this test is residuals follow normal distribution. H1 is residuals do not follow normal distribution. Level of significance is alpha 0.05. Then in test statistic category we have again KS NSW statistics. Then we write down our decision rule or criterion as usual. Here we state a condition under which H naught would be rejected, and we state it as H naught would be rejected if significance or p-value associated with KS or SW statistic is less than 0.05. Now we write down decision and conclusion, and before stating decision and conclusion we need to have a quick look on the results we are getting in the test table. So if you look at both KS related significance and the significance associated with Shapiro-Wilk, both are exceeding 0.05. Both are not less than 0.05. So we will write down the entire statement in negation this time, since p values associated with both KS and SW statistic are not less than 0.05, therefore H naught is not rejected and it cannot be concluded. That residuals do not follow normal. See, we have negated everything over here, and this is what the norm is. We need to write down the decision and conclusion in the context of each one that we are testing. So, what I have written down, significance or p-values are not less than 0.05, therefore H naught is not rejected and it cannot be concluded. So, what I have written down, the entire statement of H1, I have copied over here. This is how we perform this particular test. Okay, now moving to the next part of the question, it is further asking us to state the basis of your non-rejection in support of your findings. So we can have a quick look on the pp plot we were getting, qq plot we are getting over here. So you can notice only two observations are such that are little deviated from this line, that is the minimum and the maximum value. We can see these are the observed values and these are the expected normal scores. Expected normal scores, ideal normal scores are along this line, and you can see the majority of dots are moving very close to the line. Only two observations, this one and this one, are slightly deviated from the line, and that are not affecting, in fact, the normal behavior of majority of dots, because majority rules always. We generalize the things on the basis of majority or behavior of majority of numbers or data values. The majority of data values are following normality pattern over here on this normal QQ plot. And these two observations are a bit responsible for a slight decrease in probability over here, 0.933C Shapiro-Wilkin case. This always gives you borderline. If it is zero point 0.2 or greater, it marks as static. You can see that this is the lower bound. So we are not stated or given with the upper bound of significance or p-value for KS test, but we are given a perfect value, perfect answer for probability or p-value for Shapiro-Wilk, and this is closer to 1. Now, moving to the next part of the question, plot both original and fitted prices against weight on the same graph paper. And this is what I have done, or we have done already when we have drawn the scatter diagram. You can recall when we have drawn the scatter diagram in the first part of the question, I have done all over there. I have fitted this model, regression model, already at that instant. So we have fitted the model. What this line, straight line, is giving us the estimated values, and what these dots are. These are the actual values of the data. So you can now see that we have done this part already in question number 1 in addition to the requirement of part 1. Now we are asked to estimate in question number 8 what would be the estimated price of a ring with diamond of weight 0.248 carat. So what we need to do, we need to substitute or plug in the value in the equation of regression model to answer this part. Now our p cap, the model is minus 260 plus 3720 times w, and the weight we are given as 0.248 carat. So what we need to do, we need to simply substitute in place of w this 0.248, and this is how we get the price of estimated price rather of such a diamond whose weight is 0.248. So what we need to do, we need to substitute the values what I have substituted, and you need to work out the answer. Now this is minus 260 then plus 3720 times 0.248 gives us $662.56 as the estimated price of the diamond whose price is whose weight is 0.248 carat. So this is how we can answer this part of the question. Now we are asked to construct 95% confidence interval for beta 2, which is the slope coefficient, and interpret the result. Now this is what I have already done in the table of coefficients. You can see when we have fitted the model, I have marked a check across 95% CI, and consequently the software is giving us in the coefficients table the lower and upper bounds for 95% CI for both constant and weight, and we are asked to interpret 95% CI or confidence level for the weight coefficient, that is for the slope. So what slope measures? Slope measures the possible changes in case of 95% CIMC, the possible minimum and possible maximum change or increase due to a unit increase or change in the independent variable. Independent variable is weight, and weight is expressed in carat here. So we can be 95% confident that for a 1 carat increase in weight, the expected corresponding increase in price is greater than 3556.398, which is the coefficient value here, and less than 3885.651. This is how we interpret the answer for 95% CI. Okay. 95% CI focuses on the minimum increase and the maximum possible increase in the prices of diamond due to a 1 carat increase in the weight of diamond. Okay, now test the hypothesis at the 5% significance level or 0.05 significance level that the weight and price are linearly correlated. So for this, since correlated is the keyword identified over here, we need to focus on the correlation. So we need to first discuss what is the sample statistic and corresponding population parameter for coefficient of correlation. Coefficient of correlation lies between -1 and +1. Okay, and its corresponding population parameter is a Greek letter rho. This is how we pronounce. So now we are going to perform high pass test over here. We write down H naught, we write down H1. In H naught we write down weight and price are not significantly linearly related or correlated. Weight and price of diamonds, obviously, that I missed out in H naught, are significantly linearly correlated. Now, in the next step, we'll state or mention level of significance at which we are performing high pass test. The test statistic for this high pass testing is T, that is R minus rho, is the difference between the sample statistic and corresponding population parameter. That's the norm in stating T distribution. And then we have the standard error of coefficient of correlation. Now, since we are using p-value approach, therefore we write down decision criterion. H naught would be rejected if significance or p-value associated with T statistic is less than 0.025. Over here I would mention that we did not mention the nature of relationship between these two variables, so we need to perform a two-tailed test, and the results we would be getting in correlation matrix that we have in fact opted for already, and the output and the results are presented in the output. So we need to perform a two-tailed test less than 0.025. Okay. Now we will write down decision and conclusion. In decision and conclusion, or before stating something in decision and conclusion, we need to look at the results what we were getting in correlation matrix. This is the matrix of correlations or coefficient of correlation between weight and price. And I did discuss at that time quickly over there when I've drawn this or opted for this coefficient of correlation matrix. So there are two steric marks marked on top of this coefficient of correlation, and as such T statistics not mentioned over there in the table, but two-tailed significance is mentioned, stated, and two-tailed statistic or two-tailed probability or two-tailed significance what we are given in the table is 0.000. Therefore, it leads us to go for the rejection of our null hypothesis that what we have stated in this write-up. So H naught is rejected due to the significance of less than 0.025, which is 0 actually. So we state this as since p-value or significance in the correlation matrix is 0, therefore H naught is rejected and it can be concluded that weight and price are significantly linearly correlated. One more thing I would want to discuss here, because if you look at the output, as far as stating H0 and H1 is concerned, we did not mention the relationship between nature of relationship between these two variables, weight and price. So in terms of nature of relationship, whether it is positive or negative, this statement is not specified. So that's why we have performed two-tailed test. But the answer we are getting whenever rejection of a two-tail is occurred, it may be in the left tail or in the right tail. And in case of T, if any rejection in the left tail is occurred, this can be identified with the negative sign associated with T statistic, and vice versa. Otherwise, if rejection goes on in the right tail, so T statistic will have a positive value in that case. So what we can say after looking at the sign with the coefficient of correlation, because it is not T you mentioned over here, rather it is coefficient of correlation that would tell us the nature of relationship. If there was a negative sign linked with the coefficient of correlation, then we interpret it as inversely related to variables connected together. But since the sign of the coefficient of correlation is positive in the correlation matrix, it can be further concluded that the weight and price are of diamonds are significantly positively linearly correlated. We can add on our own this word as the part of conclusion. So better you can add this statement as well. And what I am doing, since the sign with or of the coefficient of correlation is positive, therefore it can further be concluded, or it can be further concluded that weight and price, I am continuing this statement here, that weight and price of diamonds are significantly positively and linearly correlated. This is how we can do this question. Okay.